Welcome everyone, Mr. Hyatt here. I'm going to do a stoichiometry lab today. So I've got a second camera set up on the balance. I've got a beaker set there because we're going to run our samples today with a test tube. So we're going to be able to mask both the test tube and the sample. I've got two boards I'm operating from. So I'm not sure what this is going to work out to be. So our empty test tube is 62.7 grams. Okay, now I'm going to add some sodium bicarbonate to that, I should say, baking soda. And I'm just going to try and eyeball about 5 grams. I'm going to measure it out for sure once I get finished adding it. But yeah, that should be good. Basically what I want to do is I want to be able to slide this test tube here and spread my sample out. I want to increase the surface area for my reaction to happen. So getting ahead of myself there a second. Okay, so I've got 71.4. So 71.4 grams minus 62.7 gives me 8.7 grams of baking soda in this test tube. So what I'm going to do is decompose sodium bicarbonate. Again, I want to try to spread this out as best I can. Okay. Okay, I got my flame on it. Like I said, I'm going to decompose this sodium carbonate using heat. Again, all I'm doing here is trying to get my sample to spread out a bit so that I know my reaction is happening. Okay, and then I'm just going to let it go. Okay, so you can see on this board, maybe, kind of, you can see that I have written the reaction. Okay, so I've got my sodium carbonate here, NaHCO3. That's my solid, and I'm adding heat. So eventually we will put something above the arrow to indicate that we're adding heat. Doesn't matter yet. Okay, so what's coming out of this test tube? I can see along on the sides, there's definitely water vapor forming along the sides of the test tube. If I had some universal indicator, I could put it right here, and that would show me that there's some acid escaping. Carbon dioxide acts as an acid. So I've got some carbon dioxide gas coming out the tube. I've got some liquid water forming on the sides. And then what's left down here at the bottom of this test tube, once it's all reacted, should be Na2CO3 or sodium carbonate. So I'm going to let that run as long as I can to make sure that all of that, make sure the reaction goes to completion. Things that I'm looking for as this reaction happens, I want to try to make sure that the water vapor that's forming on the sides doesn't run back down. So I'm trying to keep an eye on that as I help you guys with the math. Okay, so think about the goal of this lab. Maybe I didn't say this at the beginning, but the goal of this lab is to decompose this sodium bicarbonate and determine how much sodium carbonate is going to come from that. The gas is going to escape. The liquid is going to escape. Eventually, I'm going to shift this Bunsen burner up so that I'm boiling the water off that's condensing on the sides. So the only thing that's left in this test tube should be sodium carbonate. I want to know when I take this test tube off and I put it on the balance, I want to be able to predict what that balance is going to read. That's the goal of this experiment. So then my need, I'm putting this way up here so I can keep it out of the way. I need grams of Na2CO3. Na2CO3 grams is what I need. I know you can't see that very well. I'm given that I started with 8.7 grams, oh, I wrote G, of NaHCO3. Now, where'd that come from? I calculated it. Right, we did it right there. We said the test tube itself is 62.7. the test tube and the sample is 71.4. Subtract those two, I got 8.7 grams of sodium carbonate. Okay. Let me lay out my pathway first, and then I'll go back and fill in my numbers. And I need to get out of grams of NaHCO3. And I know I need to eventually transition to another chemical, another compound. So I know I do that through moles. I also know that I can get to moles with the periodic table. So that's good. I'll fill in my numbers here in a minute. I want to make sure I know how to get from A to B until I worry about the steps. Okay, so I'm in moles of NaHCO3. I know I can use a mole ratio to get into moles of Na2CO3. And my last step will be to get out of moles of product and get into grams of product. So again, before I add numbers, let me make sure that my units cancel. Make sure I don't have any conversion bars flipped or something silly like that. Okay, so I've got grams NaHCO3 here and then. So that cancels. So on top, mole NaHCO3. Mole NaHCO3 is on bottom here. Moles Na2CO3 on top, on bottom. The only active unit is grams Na2CO3. That's what I need, so my pathway is good. Remember the note cards that we talked about, right? Moles over grams, I go to the periodic table. When I look at the periodic table, I get 84 grams as my molar mass, 16 times 3 plus 12 plus 1 plus 23. Moles over moles, I go to the balanced equation. NaHCO3 has a 2 in front of it. Na2CO3 has a 1 in front of it. That's why it's huge that we balance equations before we start calculations. Last step, grams and moles, periodic table. I get 106 for the molar mass of sodium carbonate. Okay, so that tells me I should end up with about 5.49 grams of Na2CO3. But remember, I can't mass just the powder that's in here. I need to account for the mass of my test tube also. I've got a clump in here that I'm trying to break up. That's what you see me doing with my arm in front of the camera there. So 5.5-ish grams of sodium carbonate plus 62.7 grams. That's the test tube. 62.7. Did I say that right? Yeah, 62.7 grams. And I'll label that test tube again, just so we don't forget where that mass came from. Okay, so I get 68.19 grams should be my Na2CO3 plus test tube. So that's what my final mass should be if my reaction has gone to completion. So again, we're just using this lab to see if what we're calculating theoretically is translating to reality. So I don't see any more water vapor on the sides. So I'm going to assume that that means that our reaction has gone to completion. As I do experiments like this, I'm always trying to come up with ways that my answer might be wrong at the end. I'm always looking for sources of error. Couple of sources of error that I've seen so far. I had to break up that clump, right? So it's possible that some powder got stuck on here. I don't see any, but my eyes aren't perfect, right? I also had a little bit of wiggle in my test tube when I first put it in there. It's possible that some spilled out. Again, I didn't see it, but that doesn't mean that it didn't happen. It's very possible that it happened. Other things that could be at play here that could influence the results. I don't know how well it's coming through on the display, but we want to make sure our flame is in the right place. I'm trying to grab a white piece of paper so we've got a straight white background. I don't know if that's going to help or not, but you can kind of see, I think I do have the flame in the right place because we've got an inner flame and an outer flame, and that inner flame is breaking or is changing orange or yellow right at the bottom of that test tube. So I'm going to turn the gas off, and I'm going to let it cool down for a second. I've got test tube holders, but still, I want to make triple sure that I'm safe. If something were to happen and I were to drop it and try to catch it, I would burn myself. So I got to be extra safe at all times. So let it cool for a minute. And again, I'm expecting the reading to be 68.19 grams when I put it on the balance. If it's not that, that means my reaction has not gone to completion and I probably need to continue heating. So 68.6. Okay, so let's talk about comparing those two numbers. We have done one calculation that lets us answer the question, am I close enough? Close enough comes down to percent error, right? So 68.19 is lower than 68.6. So that's good. Mr. Hyatt would want us to be lower. That means that we have a little bit, there's a little bit of water or carbon dioxide or something that we didn't get rid of. So we didn't gain mass, we just didn't react enough of it away. So looks like we've bumped down to 68.5. So let's use that. Remember the last digit, we're always a little bit uncertain about that last digit. We're gonna take our actual minus our expected over our expected times 100 to give us our percent error. Okay, so our actual was 68.5. That's what we actually measured. Our predicted was 68.19, or our expected. We want to divide by that number as well. And we're going to multiply by 100. Hopefully you're okay with me not showing that step. So I have a 0.45% error. So that means that Mr. Hyatt did his math well and was able to do the reaction close enough for us to say, yeah, we're 99.5% confident that this is correct. So I'm really sure that I did my math right, and I'm pretty confident that I did the procedure properly. I was able to complete the reaction. So that's a basic stoich reaction and calculation to match it. We'll do a lot more like that in semester 2.